main topic is monitoring of air pollution, and this is an important concern because in particular in urban areas it has significant effect on health. So this map here shows just how many deaths are computed to result from air pollution, and you have the usual suspect in darker colors, which essentially means that the risk there is much higher. This just shows it's a significant problem. One of the things that we did over the last year, which was done by Nokia actually, who came in as a partner last year into the project, was actually to understand what would citizens be interested to know. So they started a study in Helsinki, you could imagine why, where they basically asked study subjects from 6 different families to understand what would their concerns be about air pollution. And they selected very carefully these families from different backgrounds and regions, and got then some findings which revealed that indeed people are very much concerned by this phenomenon. They're very much concerned by the fact that they don't understand the phenomenon. They even don't know what exactly air pollution is, how your perception links to the pollution, and what is then the effect, and how could you provide probably prevent strategies. So this was of course something we suspected at the beginning of the project, but this strongly confirms that this is the case. And Nokia started out of this actually to develop already a kind of potential business scenarios of how having this information available, they could provide interesting mobile services to their customers. And I just show you one example here. They call it care through air, and I think it's quite a logical thing. If you would have precise information, for example, a parent who could look at the situation of the day and then provide to the kid advice to take the bus instead of walking through some area that is probably polluted because this day is not very good for the health. So this is kind of the citizen's view. The more professional view on this is of course what public health studies does. So this is a compilation of many studies that have been performed all over the planet. So SCHÜF was the University of Hospital of Lausanne, who is actually working actively in this, has been so kind to give us this information, which just shows essentially that whichever study you look at, they all show the same thing, that air pollution increases the risk to have cardiovascular mortality, or in normal words, heart attacks, from 5 to 20%. So that's significant. And we had lots of interesting discussions with them, and it clearly shows that the effects are extremely immediate. It's completely surprising to see. I mean, you are exposed and seconds later your blood pressure goes up, and it doesn't go down for a long time, and these are significant risks. Okay, so on the sensing system, just to recall, how is it done today? So for example, the Nubble network, that is kind of the official data on air quality in Switzerland, has a few stationary stations. So you see the set networks, it's about 15 stations or so. So this has not the spatial resolution that we are aiming for. There exists mobile equipment. So the box that you see on the right is a mobile box which is about this size, but this is extremely expensive, 50K up, and it's still also quite heavy and energy consuming. Now to overcome this, there exist of course models. So the typical models today you see down on the left. These are for the purposes, for example, of a health study, 2 coarse grained. They have a resolution of 1 square kilometer or 2 square kilometers. So this is also a problem. And finally, also the data is not easily accessible. So it's of course very nice that Nubble provides interfaces, but to integrate such data then in real time with applications is still a further step to do. So what's the plan? So on the one hand, we want to take advantage of low-cost sensors that we put on wireless devices. So that addresses the cost issue. We want to exploit mobility to increase the spatial resolution of the measurements. And finally, we want to involve citizens to further extend both the potential production and consumption points of the information. And this is kind of setting the scene. So now I just give you some interesting findings that we have made regarding to these technical challenges. So we are using low-cost sensors, and that's very important to understand. There exists high-fidelity equipment at 50K per sensor, right? We want to have sensors that are on silicon basis, basically, and these are much cheaper, but also have problems in their precision. So one thing that we have been doing together with E2V, which is one of the sensor producers, is to, for example, better understand how do the sensors react on the gases, how do they react over the time under the influence of humidity and airflow, and developed good models for this. And these models, again, will be very interesting later, both for simulating, for example, the systems, but also then in the deployment for data processing. Another interesting aspect is actually how the air is brought to the sensor, right? So you can either put it into the air, that is passive sampling, or you can suck in the air into a container and then expose it to the sensor. In the second case, you have, of course, a precise localization of the measurement. In the first case, you don't know exactly where you did measure if the sensor is mobile. Now, the problem with active sniffing, which is preferable, is that sniffing takes time, right? And the group of Martinoli has been working on developing a small pump that quickly can sniff. So, and you see in the response curve that the response is now much more immediate, which is, of course, always better. Another problem with these sensors is that they're poorly calibrated. So we got basically initially said that they are completely useless for this type of problem because the errors are completely exotic. And if you look at the left-hand side, you see they're completely off if you compare to precise measurements that have been done together with EMPA by the group of Lothar Thiele. And it turns out, however, if you do some good calibration functions, you get precisions that, for example, for the purpose of health studies, are definitely sufficient. Now, this poses an interesting problem because you can calibrate if you have the high-quality measurement next to the sensor, but if it is driving around in a city, you don't have this equipment close. So how can you calibrate? So one idea is that whenever you pass by a high-precision station, you transfer the calibration to the sensor. And then the next idea is you can transfer it from one sensor to the next, and that is where some significant progress has been occurring last year with, on the one hand, real tests with sensors. You see here 2 sensors, and there were a lot of testing done to show that you can actually kind of send the calibration from one sensor to the next. And then in simulation, it was also shown how the error would develop if you do that in a multi-hop fashion. So if you have a network of sensors moving around, you can then develop strategies so that the calibrations are propagated within this network. So this was extremely interesting work together with EMPA. Now, then there are platforms. So we have public transformation as the target platform as initially described in the project. We have also robotics equipment to do measurements in wind tunnels. And recently we got also Peugeot PSA agreeing to make available electrical vehicle, you can guess why electrical, to make specific measurements. So we have plenty of platforms. I just want to give you the current status of all of the deployments that we have. So in Lausanne we have mounted at the moment 1 prototype station which is producing data. A couple of others are currently in the testing phase. They're measuring NO2, CO, humidity, temperature, and communicate via GSM with the backend. And the mobile station have, in addition, also CO2 sensors and a positioning module. So this gives you an idea of the data we get. So a small surprise was that once putting it on the bus, we thought the bus is on a line, but in Lausanne this is apparently not true. The same bus is going many different places, every day another route, which is extremely nice because we get, of course, much better spatial coverage in a completely surprising way, which we did not expect initially. So we started also to look more closely at the data. I can show you later also some of the work that has been done. So, and here is just the team that we have, and I would like to thank all of them. We have also 5 to 6 posters on most of the topics I've been talking out there. Thank you for your attention.
Karl.